So your job is just to make sure you understand what's in this packet. If you understand it, you're fine. So the rate of change is going to be my change in how the y variable changes as the x variable changes or increases. So how the y variable or dependent variable changes as the x variable increases. So we're always looking at as x is going up, what's happening to y. On a linear graph, this is called the slope of the line. Slope is written as a fraction of the vertical change, and sometimes we use a little triangle to mean a delta. So change in y to the horizontal change in x between any 2 points on a line. This remains constant or the same for any 2 points on the same line. So this point and that point would both have the same slope as the bottom 2 points, and it would have the same slope as if I took those end points. Slope as written as an m in y equals mx plus b is that coefficient, and our variable is an m. We have different types of slope. We can have a positive slope where a line is going up. Think as you're reading across. We can have a negative slope. So as we read across, it's going down. We can have a zero slope where there's no change. And we can have an undefined slope. When it's a straight vertical line, we call that undefined. And it's really because that's an x equals equation. So when you're finding a slope on the line, we're looking for 2 points, and a lot of these have 2 dots on them. So this is going to be the change in y over change in x. We say rise over run. So I'm looking how far up, how far over. I know it's positive, and it goes up 1, 2, 3, 4, 5, 6, 7, and over 4. So this slope we'd say is 7/4. And if you want to, you can write that as a decimal. There's different times you're going to want it left as a fraction and times you want it left as a decimal, but we can always change in between the two. So looking at the next one, again, I'm looking at my 2 points, and I'm going to look at that change. This is 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So my change in y is 3. My change in x is 9. And then if I look at my graph, as I read across, it's going down. That tells me it's a negative slope. So this would be negative 1/3. And this is an example of a zero slope. If I look, it's going up 0 and it's going over 4, so that'd be 0. And the last one's undefined here because I can't divide by 0. So I can't say it's going up 5 and over 0. We're not allowed to divide by 0 because we can't get back to, there's nothing I can multiply 0 to get back to a 5 because anything times 0 is 0. So that way, this is why it's undefined. So you're going to try to find the slope in the next ones. Again, we already know the positive and negative. We're looking for 2 points that are nicely on our line. So if you don't see them, you can add those in. Our slope formula is y2 minus y1 over x2 minus x1. And notice those x1s and y1s and x2s and y2s are just coming from a point. It's kind of saying I have 2 different points. I'm using a 1 to say these 2 came from the same point and a 2 to say these 2 came from the same point. And then all I'm going to do is slip some pieces in. I'm just kind of substituting them in. I'm going to label my points. So in my equation, where I see a y2, I'm going to look, the point that I've labeled as y2 is a 3. I'm looking for my y1, which is that second one there, divided by my x2 is a 4, and my x1 is a 1. So this now becomes 2/3. I can leave it as a fraction. It's reduced already, so I'm good, or I can put it as a decimal. And that's what I'm doing on every single problem. Again, I'm just looking for where's my x1 and my x2s and y2s, and I'm substituting them in. So if the first part of my equation says it's a y2, and the negative 2 is labeled as the y2. The y1 is labeled as a 4. It's always a minus. And then if it would have been a negative number, it would look a little bit different. So for example, our next two, the x2 is a 10, and I have to put the minus in, and then I'm minusing a negative 2. So this on the numerator becomes a negative 6. 10 minus a negative 2 is the same as 10 plus 2, or 12. And this would reduce down to negative 1/2. So using those equations, you're just substituting in. on the bottom part. This one's a little bit trickier. We're going to be looking at a point now and a slope. So we're trying to figure out what's the missing part of our point. And to be able to do this, we're going to need our slope formula. So I'm going to write the slope formula on the top here. Y2 minus Y1 over X2 minus X1. And then I'm going to label all my points on here. So I have an X1, Y1, X2, Y2. So now I'm substituting in. I know my M is 2. My Y2 is 6. My Y1 is negative 2. My X2 is X. And my X1 is negative 3. I'm going to simplify these down. Oops, that took out too many things. So I have a 2 equals 8 on the top and X plus 3 on the bottom. So to be able to solve, I want to be able to get rid of the fraction. To get rid of the fraction, I multiply by whatever's in the denominator. So in this case, I'm going to multiply by X plus 3. If I do it on one side, I have to do it on the other. And again, the purpose is that this X plus 3 is going to cancel with this X plus 3. So now on the right-hand side, I have just an 8. On the left-hand side, I need to do the distributive property, and if it's easier, go ahead and write that 2 out front. I get 2x plus 6, and now I'm just solving this equation. So I'm going to subtract 6 from both sides and divide by 2 so that I know that x equals 1. The x's are a little bit harder when I'm finding those. Let me show you one with a y, and then I'll show you another one with an x. When I have my m equaling a fraction, I'm going to just put that as a negative 4.5. I'm just reducing it. Negative 9 divided by 2, just so that I don't have multiple fractions. And then I have my x1, y1, x2, y2. You don't have to label. I'm just labeling so we know all of our pieces. Our slope formula starts out with our m and our y2 minus y1, x2 minus x1. And then I'm going to simplify this a little bit. I didn't need to write y2. I should just have y plus 4, keep it a little bit simpler, over negative 2. To undo that fraction, I'm going to multiply by the denominator. So in this case, it's just a negative 2. Oops, I already started doing that multiplication. So I get positive 9, negative 2 times negative 4.5. This negative 2 is canceled with that negative 2 equals y plus 4. And then I'll subtract 4 to get that y equals 5. So the y's, because there's no variable in the denominator, it just makes life a little bit easier. Let's look at number 18. That one has a variable. We'll have a variable in the denominator. Simplifying out my slope to be negative 0.2, just dividing that into a calculator. x1, y1, x2, y2. So m equals, so negative 0.2 equals y2 minus y1 over x2 minus x1. Simplifying it up. And then I'm going to multiply by whatever's in the denominator. This cancels with this. Those two are gone. And on this other side, I'm going to add parentheses around that so it doesn't look so funny. And I also have room. I'm going to put that out front because that's really what I'm doing for distributive property. It just makes it a little easier for me to visualize. I know it equals 7. 11 times 0.2 is 2.2, so negative 2.2. A negative 0.2 times a negative 1x is going to give me a plus 0.2x. And now I just solve. So I'm going to add 2.2 to both sides. 0.2x equals 9.2 and divide by 0.2. And so x equals 46.